So I think Sam and Christian set a very good foundation around some of the topics that I'm going to cover today. I think a single party, a single company cannot be alone responsible for securing software on the internet, especially in crypto. And we have all of us working together to find solutions to protect users, right? So that's key. But how do we enable more and more people to participate in protecting users? And that's kind of some of the themes that I'm going to touch upon and some examples that we've been playing with. So before I get started on to exactly what some of these approaches could look like, let's just think about an analogy. I think this is very interesting, where in software we've seen operating systems be these amazing execution environments, all the way from IBM with mainframes to Linux, Windows, Mac, and all of these operating systems have enabled cool software to exist and create value for end users, right? And now we're in the crypto land where we're seeing smart contracts enable code, right? Now what's interesting is traditionally, all of these softwares were distributed by most likely centralized companies. You have the IBMs of the world, Apples, Microsofts, etc. And they would be able to control who can publish software. And at the same time, they had the ability to censor any software that they did not think was useful, applicable, or paying the 30% tax to them, right? So now we're in crypto, where MetaMask snaps can be thought of as this execution environment where we could enable the functionality of MetaMask from a wallet to almost an operating system. But in doing so, do we always depend on MetaMask to ensure the safety, the security, as well as who can write those snaps? And I think that's where MetaMask is very open about their end goal or end game, that we need a permissionless distribution system for snaps. And that's the cool part. But the scary part is, how do you do it while being permissionless and inviting all the different stakeholders through it? So some of the goals which are very applicable for MetaMask snaps as well is, hey, we want more and more MetaMask users to actually discover snaps. But we also want users to not fall prey to malicious snaps. And we don't want to censor which snaps make it to the MetaMask directory or Snap Store or whatnot. So some of these goals are exciting, but also difficult and complex to achieve. Now let's take a very quick look at some of these examples of permissionless innovation in crypto. That's it, right? In crypto, we have Farcast. How many of you are on Farcaster? Just curious. So we have a few people. And Farcaster launched Frames recently. Does everyone know about Frames, the folks who are on Farcaster? Yeah. So Frames is a very cool piece of functionality, but constrained functionality, which allows developers to build interesting interfaces for users. But what Frames is a very constrained sandbox. It's not your wallet. Today you can only do limited things with Frames. You could click and see new images within your feed. Of course, they will extend it. So Frames is anyone can build cool software on Farcaster social graph. MetaMask is anyone can build software, but that software is attached to your wallet, to your keys. So how do you protect users to not get money drained from their wallets? It's different from letting users on social media have cool apps in their feed, right? So these are two good examples of permissionless innovation, but the stakes are so much higher here because you're interacting with your wallet. So how do we think about protecting it? Right now in Farcaster, anyone can ship frames. There's also a bunch of spammy frames there. But thankfully, they don't touch your keys because they use a different key format for your Farcaster handle. So again, where we are at is snaps today are allow listed. There are permissioned security auditors, some of us in the room, who are checking, manually reviewing if these snaps have the correct code, they're not vulnerable, and approving snaps to go onto the directory. But down the line, we want anyone to be able to publish a snap and anyone to come together and say, hey, this snap is actually malicious, and not just 5 people sitting in this room today, right? So how do we get from there to here is what we're trying to explore. And it will involve a lot of overcoming security challenges, right? So the approach that we've been thinking hard about is introducing reputation graphs. Now, its underlying principle is that trust and reputation is transitive. Let's say if I trust Forta and Forta trusts, Hexagate, there's this reputation circle that we've been creating, which is pretty much how we kind of, use the system of thinking we use in real life. Like, hey, who do I trust? I trust MetaMask to just go and approve these snaps. That trust is already there. I'm just delegated it to MetaMask. But here I can delegate trust to a series of security experts. Pretty much what Sam was talking about with the SEAL team that he's trying to create, right? And what we can do here is use peer-to-peer trust signals to create a reputation graph, almost forming a decentralized web of trust. That's the true power of this decentralized internet that we want to capture. And then you could do verifiable compute on top of it. Not a closed-door trained machine learning algorithm, but an open, verifiable algorithm. Of course, it opens up the gates for black hats to come and break it, but that's cool. We want that. You could apply compute on reputation graphs, come up with scores for users, for snaps, for any software, artifact, and enable safety and discovery. So that's the approach that we're going down, and we would love to get feedback from some of you guys. How do we start? Every single EOA, if there are 300 million EOAs on Ethereum mainnet today, our goal is to, hey, can we create some kind of a reputation score for these EOAs? What if every user had a reputation score? Today, I trust Consensus, I trust MetaMask, I trust OpenZeppelin, because they've demonstrated that trust and I can know where to find them, but we're in a Sybil-prone environment. The only way we can trust those voices is we figure out, hey, who is trustworthy? Before I listen to anything they say, right? So before I look at a point of view, I want to know how trustworthy they are. So it starts with a user reputation graph. In this case, trustworthy security auditors can come and say if a snap is safe or not. Not just MetaMask, but the SEAL team and every single person, if we all think that there's a group of trustworthy peers here, then they could voice their opinion through an on-chain or off-chain attestation, which would create a trust graph. And this would create some kind of a reputation for a snap. You could have a feedback loop for reporting or disputing malicious snaps. So really, what are we sitting on here possibly is an opportunity for users to build on-chain decentralized reputation, which is not owned by Apple, Facebook, Google, or any single company. Because guess what? It's all EOAs. It's public-private keys. But reputation for software security experts, pretty much like the SEAL team that we talked about in the morning. And even for developers. Developers who've shipped smart contracts which have been safe for 8 years, like Andy was talking about, hey, if the age of a contract is 8 years, and guess what? 10 other developers trust that developer. Now that transitive trust helps you build reputation. And what if we could use that reputation for safety, security, social discovery? What if Zach XPT doesn't go on Twitter and say, hey, I'm calling this smart contract unsafe? They just report a snap, and suddenly, in a matter of a few seconds, possibly milliseconds, you would actually be able to see that this is flagged by a reputable auditor and just uninstall it. So that's kind of the web of trust that we're trying to use. How does this work? So this is a prototype we're working with the MetaMask Snaps team, where there's a permissionless snaps directory. Anyone can publish a snap. We're bootstrapping a reputation graph of some security auditors and researchers who are going to say if a snap is trustworthy or not. And based on that, we have a verifiable compute going on, which just gives the snap a score. So all of this is live, and I'm going to, towards the end, share a QR code. We would love for all of you to actually go and participate in the system. But what does it all look like? What does it boil down to? So every single snap, so a Bitcoin wallet snap, can have now a reputation label or a score, which is a community sentiment. It's backed by what people are saying about it. It's backed by what reputable people are saying about it. So if a snap receives all endorsements from reputable security auditors, it's endorsed by the community. If you've seen Twitter's community notes, that's probably one good example to think about how community voice can help fight, let's say, fake news, but here we're solving a tougher problem, which is, fake software which can drain money. But if everyone in the community of security auditors thinks that a snap is safe, it's going to be endorsed. If we don't have enough reputable people endorsing a snap, insufficient reviews. Again, we're bringing matter-of-fact information to an end user and giving them useful information before they have to go and inspect smart contracts themselves. If a snap is clearly reported by even one reputable auditor, it's reported. And if there's a debate going on, it's in review. So there's many interesting things you could do. All of the logic here for processing these labels is open source. You can change it anytime. It's not hard-coded. It's not behind a opaque scoring system. So that's kind of the cool part where we're opening up this tool to the community to come and create a reputation system for snaps. So I'll give you a small example from the live system that we have. There's a happy path. There's a Starknet snap right now, which has 27 endorsements. 23 of them are from, 23 endorsements in 4 reports. But this snap is still endorsed, which means that the 4 reports are not from reputable people. Expected behavior should be endorsed. Now, the cool part is this is a reputation. This is the actual reputation graph behind that snap. You could see who are the people who are endorsing this snap and who is the person who's reporting this snap. Now, why this snap is still endorsed is because the reputation of the person who reported this snap is not high enough. Which means if 1,000 Sibyls try to DDoS a snap or report a snap, it will not affect that snap. And that's the resilience we want in the system. So this is a happy path. All of us are excited, great systems working, but let's take a look at the unhappy path. I have a Solana wallet snap. It's in review. If you see these light yellow, these are the highly trusted, reputable people. There are 2 or 3 who are endorsing, but there's 1 who's reporting the snap. So what do we do? So it's in review. Now this is where the system is actually functioning as intended. This is not endorsed or reported. There is a feedback loop that we have. And this is what we were talking about, is if a Solana wallet snap suddenly gets a report from a trustworthy auditor, how do we have that feedback loop quickly, in a trustworthy way and in a resilient fashion? So we talked a lot about feedback loops. We have the GitHub repo for phishing sites. Great, optimizes on speed. But what about trustworthiness, right? How trustworthy is a report from someone, whether a site is phishing site or not? And secondly, resilience. What if someone who's trustworthy today is not trustworthy tomorrow? How fast can the system respond for a sleeper agent? Someone who's built up a reputation over time and then suddenly decides to take all the money away. So we need the system to actually withstand all of these attacks. And only then we'll be able to be fully ready for a permissionless setting. So we're running this with the MetaMask security team, some of these attack scenarios, and it'll be cool to help get some of you to participate as well. Now coming back on the Solana wallet snap. This is a Dune dashboard. It's live right now. All the links are there in the presentation. You could see the timestamp on when this snap's status changed from endorsed to in review. If you double click, you will see the security score of the user who reported this. And suddenly you have a quick feedback loop. This verifiable compute happens every 2 minutes right now. It can happen in a few seconds if we just add more resources. And you have open reputation graphs, creating an open feedback loop for snaps. And again, all of the logic of what should be endorsed, reported, can be firmed up with machine learning over time, right? But it's all open source. So this is an example of using reputation graphs, real-time data, real-time verifiable compute to try and create a decentralized reputation system for users and for software artifacts like snaps. So this is how a user reputation graph looks like. You can go to snaps.k3l.io, and you can actually see it. We would love for all of you to be here. There are certain yellow, highly trusted peers which are from the MetaMask security team today. Or if you want to be highly trusted, just share your EOA. Like, obviously, you have to dox your EOA, and ask them to endorse you as security experts. And if you become highly trusted, then you can go and report or endorse a snap that you see easily, without having to ask for permission from everyone or anyone here, right? So this is a user graph. You can see how a highly trusted peer looks like. Accuracy. How many times does a security auditor get their reportings right? And it's okay, sometimes we all miss things, but this is just a matter of fact metric, right? What did a security auditor say about a snap, and eventually what the snap status was, right? So you as a user could say, I trust someone who's 90% right versus 100% right because their 90% is for the last 5 years versus someone who just got lucky with one right report. So there's a bunch of very cool things you could do with this, right? And all of the scores are verifiable. Compute can be done on a local server for you to test out that this is not forged. The final piece is, if you're excited, we have a implementation of this entire compute system in Rust. We're using EigenTrust, which is a variant of PageRank. And we're actually on Friday announcing the protocol. It's called OpenRank. It's a decentralized reputation protocol. And this is one use case which is leveraging the compute of decentralized reputation. So you could see how the algorithm works. Everything that I showed you right now, the snap score, the user score, how they're derived, what are the parameters, how many times does the compute happen, is there in the README on our repo. So please give us feedback, break this apart. We want to be, we don't want to just get this right in one go. It's not possible, to be honest. So we want all your support in fixing any of the attack vectors that we're testing right now with the MetaMask Snaps team. But this is a small example of how a decentralized community-based reputation system is inevitably needed for permissionless innovation in crypto. So as I promised, here's the QR code. You can go and start looking at your own profile, report or endorse snaps, each other, request for endorsements by participating here. And this is where we drop all announcements related to this experiment we're running. Cool. Thank you so much.
You incentivize people to endorse or report or attest to these?
Fantastic question. So
What was the question? To repeat to the people.
How do we incentivize people to endorse or report? So honestly, I think and I've been building in crypto for the last 8 years, and if I had to answer this question 6 years ago, I would say, launch a token, future promise, like, hey, but today I don't think financial incentives are the right way to create a community here. So the endorsement comes from building social capital. So if all of us are security experts here, or want to contribute to a security expert white hat community, we would just play to participate and play to kind of earn that reputation, which means right now we care about quality over quantity. So right now we're opening the system up only to hardcore security experts who want to participate. And then over time that graph grows. But I think another learning of building a decentralized reputation system is it has to be intentionally curated versus get 1,000 people to build a graph which may not be high quality. So that's our current stance. There's no like right answer to it, but I think this is just based on learnings on the context of problems we want to solve with this reputation.
Any other questions? We good?
What was the name of the protocol that you guys are? Sorry. What was the name of the protocol that you're launching?
It's called OpenRank.
OpenRank.
And so we use eigentrust, hubs and authorities, PageRank, kind of collaborative filtering, kind of social graph algorithms, but in a verifiable computation way.
Awesome. Round of applause. Thank you so much.
Thank you, Francesco.